Good afternoon, my dear students. In the last class, we have discussed till ethers. We have discussed till ethers. Today, in this class, we are going to discuss about the remaining functional groups and classes of organic compounds. First one, carboxylic acids, carboxylate ions, esters, acyl halides, amines, amides, nitro compounds, and the last one is sulfonic acids. Now we go to carboxylic acids. See here, you can see the functional group structure for this carboxylic acid. So this is COOH. Here it's a bond COOH. For this, the prefix IUPAC prefix will be carboxy and the IUPAC suffix will be oic acid. That means while you write the IUPAC name for the carboxylic acids, you should end with the suffix oic acid. Oic acid. Okay, see, now I'll write down the functional group structure for the given class of compound, that is carboxylic acid. Carboxylic acids. Here they have given you bond COOH. COOH. This is a bond which is connected to this group, that is COOH. That means we are having one carbon, two oxygen atoms and one hydrogen atom. Already I told you that towards this left side of this bond you may be having two groups. One is alkyl group, the other one may be phenyl groups. That means alkyl groups are aliphatic. If phenyl group is present, it will be considered as aromatic. Okay. Now this structure can also be written as alkyl bond C double bond O bond H. So you can write this structure like this also. Everybody knows that there will be two lone pair of electrons on oxygen. So for oxygen there will be two lone pair of electrons. See students, do you know what is the difference between lone pair of electrons and bond pair of electrons? What are lone pair of electrons and bond pair of electrons? See here. Lone pair of electrons are nothing but they do not participate in the bond formation. See here, lone pair of electrons are nothing but those are the pair of electrons. They do not participate in the bond formation. That is called as lone pair of electrons. Next, coming to bond pair of electrons. Bond pair of electrons. These bond pair of electrons are nothing but they will participate in the bond formation. So the pair of electrons which participate in the bond formation are called as bond pair of electrons. Okay. Next we go to carboxylate ions. Now what are these carboxylate ions? Here they have given you bond COO minus. For this the suffix is O8. suffix is O8. You should end with the OATE while writing the IUPAC nomenclature. Okay, now I'll write down this functional group structure for carboxylate ions. Carboxylate ions. They have given you in the textbook, they have given you like this: bond CO minus. We know alkyl or pH. Now how we are getting this structure? From where we are getting this structure? See here, as already we have discussed, acid, RCOH is the acid. When the bond which is present between oxygen and hydrogen atom breaks, when the bond between hydrogen and oxygen atom breaks, it will split into ions. It will split into ions. I'll write it here. When the bond is breaking between oxygen and hydrogen atom, oxygen is more electronegative when compared to hydrogen. Oxygen is more electronegative when compared to hydrogen. Okay, so the term here I am explaining you the term electronegativity. What is electronegativity? Electronegativity is nothing but the capacity or the ability of an element to withdraw pair of electrons towards itself. So oxygen is more electronegative, it will withdraw both the electrons towards itself. So if it is withdrawing, if it is taking, it will acquire negative charge. So we can write the structure like this: oxygen will acquire negative charge. The remaining groups I am going to write like that only, but what is the difference here? It will acquire negative charge after the breaking of this bond, and the charge which is acquired on hydrogen is plus, positive. So here you can see hydrogen is the electropositive element, oxygen is the electronegative element. See here you have got two types of ions. One is RCOO minus, the other one is H plus ion. So H plus ion, there is a name for H plus ion and there is a name for RCOO minus. So these two names I am writing here, I am taking here. So here we are getting two types of ions, that is R, C, double bond O, O minus, and H plus ion. This ion is called as RCO minus ion is called as alkylate. This ion is called as alkylate ion. Alkylate ion. This ion is called as alkylate ion. And then the name of this H plus ion is nothing but hydrogen ion, or it can also be called as proton. So here RCO minus is nothing but alkylate ion. If alkyl group is not present, the general name for this general name they have given you carboxylate ion. They have given you the carboxylate ion. Okay, next we go to esters. Esters. The functional group structure for esters is bond COOR, and the prefix given here is alkoxycarbonyl. I'll explain you what is alkoxy, what is carbonyl group. Here it is a combination of two terms. I'll explain you and I'll give you the formula for alkoxy and what is carbonyl. And then we go to the suffix. What is the suffix should be given? While we write for the IUPAC nomenclature, we should mention it as O8. That means the IUPAC name should end with O8. Now coming to this, as I already told you, I will tell you the formula for alkoxy group and carbonyl group, and then I'll write down the COOR group structure here. Esters. The general formula for esters is RCO O bond R. RCO O bond R. Here two oxygen atoms are present and here two alkyl groups are present. These alkyl groups may be same or these alkyl groups may be different. Here also you can split, you can break the bond like this. If this is acquiring positive charge, that means alkyl groups are always positively charged. Positively charged species. Positively charged groups or species. Whereas here it will acquire negative charge. Oxygen atom will acquire negative charge because of its more electronegative nature. So we can write this as R C double bond O O minus. So this is nothing but alkylate ion. This is nothing but alkylate ion. Now we have seen here the prefix was used was prefix for this is alkoxy carbonyl. Here you see alkoxy is one term and carbonyl is one term. Alkoxy is nothing but bond OR. Okay, alkyl and oxygen. This is nothing but alkyl plus oxygen, alkoxy. Here alkyl groups. What are alkyl groups? Already I have told you. First member is CH3. The first member is CH3. This is methyl. Next, this is ethyl. This is propyl, butyl, pentyl. You can go like this. You can take any number of alkyl groups. So the general formula for alkoxy group is OR. Okay. What is carbonyl group? Carbonyl group is nothing but C double bond O, and on either side of carbon there will be two bonds. C double bond O, on either side of carbon there will be two more bonds. Why we are placing two more bonds? In order to satisfy the valency of carbon. As you already know, the valence of carbon is 4. You already know the valence of carbon is 4. What is valency? Valency is nothing but the combining capacity of an element with other groups or elements or atoms. Valence is nothing but it's the combining capacity of an element with other atoms or groups, or it may be any other group. So for carbon it is 4. That means carbon will combine with 4 other, it may be same groups or it may be different groups. So this is the carbonyl group and this is the alkoxy group. Suppose here this is alkoxy group. If I am taking methyl group, if I am taking this methyl group in the place of R, you can see here OR, this is bond. As I told you, I am taking methyl group in the place of this alkyl. I am substituting methyl group in R. What is the name for this will be methyl plus oxygen? Methoxy. The name of this group is methoxy. See here already alkoxy is given. So under alkoxy we can have the first member. This is the first member. This is the first member of alkoxy group. Now you can guess what is the second member? Ethoxy, propoxy, butoxy, and so on, pentoxy, like that. Ethoxy, propoxy, butoxy, and like that. Okay. Now we go to the next, acyl halides. The next class of compound is acyl halide. Halide means nothing but halogens. We will be having halogens. Here you see if you go to the functional group structure, this is bond COX. Bond COX. The prefix will be halocarbonyl. Halo means halogen atoms. Fluorine, chlorine, bromine and iodine. Okay. Halo means halogen atoms. There will be fluorine or chlorine or bromine or iodine. And then carbonyl is nothing but, I told you earlier in the just now, C double bond O is nothing but carbonyl group. And then the prefix suffix is oil. OYL, oil halide. Oil halide. That means this should be come at the end of the, while naming the organic compounds. When this group is there, when this class of compound is given, you should end with oil halide while writing the IUPAC nomenclature. Here COX is given. Now I'll write down the COX group. I'll write down the COX group. Acyl halide. The next functional group is acyl halide. Acyl halide or acyl halides. Bond COX. Now what is X? C double bond. Now we can write this is as C double bond OX. Like this also we can write. X is nothing but X is equal to fluorine or chlorine or bromine or iodine. X may be fluorine, chlorine, bromine or iodine. Now next we go to the next class of compound, that is amines. Amines. How we are getting amines? First of all, you should know how to prepare amine. See, everybody knows the formula for ammonia. All of you know the formula for ammonia. Here amines, the general functional group structure given is NH2, bond NH2. Below NH, 2 bonds NH and 3 bonds, 1, 2, 3 bonds with N in the middle. For nitrogen, the valency will be 3. What does it mean? Valence is nothing but its combining capacity with other atoms or groups. So for nitrogen, the valency will be 3. That means nitrogen can combine with 3 other atoms or groups. Now I'll take the formula here on the paper. Before writing this formula on the paper, you see the prefix amino. Amino is the prefix and amine is the suffix. Amine will be the suffix. Now you see here amines. They have taken the general formula amines. Amines. Bond NH2. As already we know, if there is a bond, there may be alkyl or pH groups. Alkyl groups or pH groups. Now, from where we are getting this? From where and how we are getting this group? See, everybody knows the formula for ammonia. NH3. NH3 is the formula for ammonia. See, how many this NH3 can also be written as like this: hydrogen, hydrogen and hydrogen. Nitrogen can combine with 3 other atoms or elements, or it may be same or different. See here, one lone pair of electron will be present on nitrogen. Here 3 hydrogens are there. If one of the hydrogen is replaced with hydrogen. If one of the hydrogen is replaced with hydrogen, the formula will become R like this. Okay. So this is nothing but this one. Is this clear? This is nothing but RNH2. So this one and this one are both same. That means these amines are derived from ammonia. These amines are derived from ammonia. That means one of the hydrogen atom is replaced with alkyl group. This is R. Replaced with alkyl group. then the formula will become like this. You can write like this also. So everybody knows one lone pair of electron will be present on nitrogen. Here, while discussing this amines, I am going to tell you about the three new terms. First one is primary, three types of amines. There will be three types of amines. Three types of amines will be present. Three types of amines will be present. Primary amine, the second one is secondary amine, third one is tertiary amine. Tertiary amine. Now going to first one. What is primary amine? Primary amine. What is primary amine? Here you see nitrogen will be having 3 bonds. All the bonds we will satisfy with some groups. Now these 2 bonds are satisfied with hydrogen, and if one of the bond is satisfied with the alkyl group, okay, if one of the bond is satisfied with alkyl and 2 other groups are hydrogens, if the nitrogen is attached to one alkyl group, here in this formula you can see nitrogen is attached to one alkyl and 2 other hydrogens. Alkyl is only one. That means this nitrogen atom is considered as primary. This nitrogen is considered as primary and it is coming under amines. That's why we can call it as primary amine. That means based on the number of alkyl groups attached to the nitrogen, based on the number of alkyl groups which are attached to the nitrogen, if one alkyl group is attached, it will be termed as primary. If there are 2 alkyl groups, see, if there are 2 alkyl groups, that means alkyl, alkyl and one hydrogen. Now this nitrogen is attached to 2 other alkyl groups. This is called as secondary amine. Secondary amine. You can also write as primary NH2, secondary NH2. Similarly, tertiary. This is the second one. This is the third one. Tertiary is nothing but all the bonds are alkyl groups. All the bonds which are present on nitrogen will be filled with 3 alkyl groups. So this is tertiary amine. Tertiary amine, or you can also write it as tertiary NH2. So these 3 are the concepts which are present or which are to be learned in this amines, in this class of compound, that is amine. That is amine. So based on these concepts, they have given you here. Here they have given you CnH2. That means this is primary, this is secondary, this is tertiary. Once again I am repeating. This is primary amine, this is secondary amine, and this is the tertiary amine. Next we go to amides. The general formula for amides is, general functional group structure or the general formula for amides is CONH2, CONHR, CONR2. Why they are taking these 3? CONH2, CONHR, CONR2. That means here you can simply understand that number of hydrogens are replaced by alkyls. Here 2 hydrogens are there. Simple, it's very simple. Hydrogens are replaced by alkyl groups. So they have mentioned you like this here. No need to get confused. It is very easy. It's very easy. No need to confuse. And then what is the prefix? Carbomoyl. Carbomoyl is the prefix and the suffix is amide. Amide. CONH2. Next, nitro compounds. NO2. Simple. This is the, just substitute. This is the bond NO2. Okay. Nitro is nothing but, NO2 group is called as nitro compound. Nitro is the prefix. There is no suffix. After explanation of all this, till here, I'll explain you all the examples. Last one is sulfonic acid, SO3H. So this group is called as sulfonic acid. This group may be attached to the aromatic ring, that is benzene ring, or it may be just present in a normal chain, open chain, that is aliphatic. Okay, so sulfo is the prefix and sulfonic acid is the suffix. With this we have finished by today's class. We have finished the functional groups and the different classes of compounds. All the different classes of compounds we have finished. Different classes of compounds. In the next class we are going to discuss each and every example, and under each and every example you need to solve more as many as possible. You need to solve more examples. So finally, all the functional classes of compounds, we have finished all the classes of compounds. I have explained you all the functional group structures, prefix, suffix. In the next class we will deal all these examples. Thank you, dear students.